Here we have a SAT math problem. Okay, let's go to the question. The graph of f of x equals to x negative a times x negative 3, where a is a constant, is shown in the xy plane above. If the y-intercept of the graph is 3, what is the minimum value of f? Okay, here we have a quadratic function in factor form, and its graph is given over here, a vertical parabola which opens up. Okay, now to get the minimum value of the function f, we have to consider the y-coordinate of the vertex of this parabola. Okay, if I want to get the y-coordinate of the vertex of the parabola, first I have to find the x-coordinate of the vertex. Okay, for that we have to consider the given quadratic function. Actually, the given quadratic function is not complete because it contains an unknown constant a over here. Okay, now to get the x-coordinate of the vertex, first we have to get the value of this constant a. Okay, now let me consider the information. There is a y-intercept of the graph is 3. So here we have the y-intercept, that is the point at where the graph intersects y-axis. So y-intercept is 3, there is 0, 3. And also when we have graph for a function like f of x, so this f of x represents a y-coordinate in the xy plane. So we can replace this f of x by y. Then the given quadratic function will become y equals to x negative a times x negative 3, and the graph of this quadratic function, that is a parabola, passes to the point 0, 3. That's a y-intercept. Since it passes to the point 0, 3, we can plug in this x coordinate 0 for x over here, and the y coordinate 3 for y over here. Okay, now let me do it. Then I'm getting 3 equals to 0 negative a times 0 negative 3. 3 equals to 0 negative a is negative a, and 0 negative 3 is negative 3. Then we get 3 equals to negative times negative will become positive. A times 3 can be written as 3a. Let's divide both sides of this equation by 3. Then this 3 will cancel out. 3 divided by 3 is 1. Okay, here I got the value of a. So the value of a is 1. Okay, now what we can do is we can plug in this value 1 for a over here. Then the given quadratic function will be complete. That is, we get y equals to x negative 1 times x negative 3. Okay, now to get the x-coordinate of the vertex, what we have to do is we have to find the two x-intercepts of this parabola. Okay, to get the x-intercepts of this parabola, what we have to do is in this equation, we have to plug in y equals to 0. Because of the x-intercepts, always the y-coordinate is 0. So now let me plug in y equals to 0 to get the x-intercepts. Okay, when y equals to 0, then this stuff, the stuff we have for y also must be 0. That is x negative 1 times x negative 3 equals to 0. Okay, here the product of two binomials equals to 0. When the product of two quantities equals to 0, the first one has to be 0 or the second one has to be 0, or both of them may be 0. That is x negative 1 equals to 0 or x negative 3 equals to 0, so that the product can be equal to 0. Okay, if I solve for x in this equation, I'm getting x equals to 1. That is, I have to add 1 to both sides of this equation. Now to solve for x in this equation, I have to add 3 to both sides of the equation. I'm getting x equals to 3. Okay, here I got the two x-intercepts. 1 is over here and 3 is over here. Okay, now to get the x-coordinate of the vertex, what I have to do is I have to find the average of the two x-intercepts. Okay, now let me find the average of these two x-intercepts. For that, we have to add the two x-intercepts and divide by 2. Then I'm getting 4 over 2, which is equal to 2. So 2 is the average of these two x-intercepts. Actually, this average of the two x-intercepts, this 2 is the x-coordinate of the vertex. Okay, here I got the x-coordinate of the vertex. Let's assume the y-coordinate of the vertex as k. Okay, here the parabola passes through the point 2, k, which is a vertex. Since the parabola passes through this point 2, k, we can plug in this point 2, k into this equation. And when I do so, I have to solve for k, which is the y-coordinate of the vertex. Okay, now let me plug in this point 2, k into the equation of the parabola. Then I'm getting, I have to plug in this y-coordinate k for y over here. Then I'm getting k equals to, and for x, I have to plug in the x-coordinate, that is 2 negative 1 times 2 negative 3. Then I'm getting k equals to 2 negative 1 is just 1, and 2 negative 3 is negative 1. Then I'm getting k equals to 1 times negative 1 is negative 1. Okay, here I got the value of k, which is y-coordinate of the vertex. Actually, as I said already, so the y-coordinate of the vertex of this parabola is the minimum value of the given function f. Therefore, the minimum value of f is negative 1, and we find negative 1 in answer choice A. The correct answer choice for this question is A.